Hey everybody, so today I'm going to be making a tutorial out of the Statistics Informed Decisions Using Data book by Sullivan. This book is, I'm thinking, the newer version, and so the cover has a bunch of people and they're like running, but it's very similar to the book that has the red shoe on it. I'm going to be going over section 3.2 right now, which is measures of dispersion. Specifically, I want to talk about the empirical rule and what we use the empirical rule for and what it actually means. So, I guess let's get started. So, we have the empirical rule. So, the empirical rule tells us, based on where we lie and what our standard deviation is, the amount of data that should be from one point to the mean. So if we explain that in simpler terms, things that you need to really be able to tell how the empirical rule is going to work is your mean and your standard deviation. So in this case, we're going to kind of use a standardized form where our mean is going to be 0 and our standard deviation is going to be 1. So looking at it, if our mean is 0, that means it's here, and our standard deviation is 1, which means in increments of 1, each standard deviation is going to increase. Same thing on the opposite side, except it'll decrease by the standard deviation. So the empirical rule takes the time to explain that from one standard deviation away on both sides of the mean, there is going to be 68% of the data that will lie in this interval. And then it goes to tell us that from 2 standard deviations away, on either side, we are going to have 95% of the data. And on the last one, we are going to have 99.7% of the data. That will lie in this interval. So the empirical rule is telling us that if we're ever looking for something, we should be able to find it based on these numbers and what they're telling us. Now, another way to break it down is to show how much is within each standard deviation. So if we break it down, same thing, our mean is 0 and our standard deviation is 1. If we have 68% of the data falling in here, 68 divided by 2 is 34. So from 0 to -1, 34% of the data will lie in here. And from 0 to +1, 34% of the data will lie in here. Now, for the next one, from -2 to +2, we know that 95% of the data lies between -2 and +2. So what we're going to do is we're going to do 95 minus the 68 that we've already accounted for. And when we do that, we can bring it over on our calculator. Excuse all this stuff. 95 minus the 68, and that gives us 27. And because we have two sides, we're going to do 27 divided by 2, and that gives us 13.5% on one side and 13.5% on the second side. Now, for the last part, we can do the same thing. We know that the last portion has 99.7% of the data. So, 99.7% of the data. So we're going to do 99.7 minus the 95, and then we're going to get our answer, and we're going to divide it by 2. So just to be clear, we have 99.7 minus 95, which gives us 4.7, and we're going to divide it by 2, and we get 2.35. So that means in this last portion, there is 2.35%, which means there's like a little tiny bit left over. Now we know that the total area under the curve is equal to 1. This is also 100% if we're talking in percentages. So we've accounted for mostly everything, but there's still a little bit that we haven't talked about. So for this last little part, we could do 100 minus 99.7, and whatever that is, we'll divide it by 2. Which is, 0.15 or 15%. Or excuse me, 0.15%. So that shows the breakdown of each and every one of the, the layers in the empirical rule. Another way to remember the empirical rule is that it's set up as kind of an addition or a subtraction equation. So we have our mean here. One standard deviation to the right is going to be, hopefully you guys can see this, is the mean, the mean plus 1 standard deviation. Then when we move one more over, it's the mean plus 2 standard deviations, and then the last one is the mean plus 3 standard deviations. The same can be said going the opposite way. For the first one would be the mean minus 1 standard deviation. The next one would be the mean minus 2 standard deviation, and the last one would be the mean minus 3 standard deviation. Either one of these ways all represent the same information or the same data. They just show you how and why the empirical rule is broken up the way it is. I hope this gives you a little bit more of an understanding of the empirical rule, and I will post some more videos soon.